Hello everyone, welcome to another episode of Azure Database for MySQL Troubleshooting Series. I am Rahul Saha and I'll take you through the topic troubleshooting query performance in Azure MySQL. I'm sure everyone faces issue related to performance in MySQL engine, and I'll speak about it today in the context of Azure Database for MySQL. I will cover how do I find the problematic query and what best can be done to make the performance better through a detailed demo. Troubleshooting query performance includes several steps and it can go more complex with different set of queries. While you go through the demo, I would like to show you how to log the queries, review the information of logs, and explain and profile a query. And finally, the HLL value, it stands for history list length, and it is the amount of changes records in the undo log. And higher the number, it's more problematic for the database performance. So we'll look into more details of HLL in the upcoming slides. Let us get started. How do you log queries? By enabling the slow query log. And this is the first step. How do we troubleshoot our query? Let us assume that some queries are being executed from the application in MySQL database, and those queries are running slow. The first step is to log those slow queries in the slow query logs. After that, we do a couple of things which are like explain and profiling, and finally finding the HLL values. Explain is a way to find out how that query went through different path. So that will give us more information about the index being used, partition being used, and all the other information related to the query flow. Second, coming to profiling, it gives more information how the query flows through different path and how much time being taken in each and every step while a query flows. And third part is the HLL. So as I mentioned, it's the growing value of HLL is a way to show that it is not performing good and it needs to be really looked into. Let's assume that we find out that HLL value is below 10,000, which means it's quite normal. And when it goes beyond 1 million, it needs an intervention which can be easily investigated and it can be easily mitigated by different several processes. Next, we'll be looking the best practices for running the query. It is always good that we don't be reactive and find the problematic query always. It is always good to set up some best practices for your production workload. So first of all, we need to have enough of resource present for a query to run. Initially, whenever there is a production system, enough of benchmarking tests should be done so that the correct size of the server or correct size of the SQ can be figured out and that can have it set up for the production system. Once the production system runs on, it's a continuous monitoring to find out if the CPU or the memory is correct or it does not cross the threshold so that the query becomes slower. The second point is to avoid long running queries. It is always a good practice to break down the queries into smaller transactions. Next point is like InnoDB purge thread. This is one of the important parameter where you should set up the correct thread and it always depends on the workload. So more amount of workload, the thread should be more so that the purge activity can carry on in the background without any issues. Next point, you should configure the alerts so that you can get the regular alerts and you don't miss out on any mishappening happening in the database system. Also, at the regular interval of time, you should collect all the diagnostics because that can give different set of information which can be easily mitigate the issue related to performance. And the most important thing other than all these are like you should always enable the Azure workbooks. It also gives a UI interface where you can also see these slow running queries. Setting right value for long query time is very important because it logs the query based on the mentioned time for this parameter. If the value is very less, it will log all the queries, and if the value is very large, it will not log any queries. So setting up the right amount or right time is very much important for this query to work, and it will log the correct amount of logs in the log file based on the value mentioned in this query. Now let's look into the demo where I'll show you how to configure the logins, how to retrieve the information from logs, and how to check the explain plans and the profiling settings. To enable slow query logs, we need to enable parameters in server parameter blade. The parameters which we'll be modifying are long query time. So this parameter is responsible mainly to log queries above the mentioned seconds. For example, if it is 1 second, it will log the query above 1 second. Second is slow query log. This is the parameter which enables or disables the slow query log. After we change, we save all the parameters so that the effect takes place. Also, there is one more important parameter which is log queries not using indexes. This parameter should be generally off. The reason behind it is that it should not log the queries without the indexes, or else we will not be able to gauge the actual slow queries. Next, we move on to check all the queries where it is getting logged, which is inside the server logs. Inside server logs, there are settings like enable it, which enables or disables it. Then there are settings like disabling or enabling the slow query logs. And at the bottom, we can see all the slow queries which got logged in different files. And the latest ones are always at the bottom. Now we'll be running some queries from MySQL prompt so that we can check if the queries are logging into the log files or not. So I'm changing the database to one of the database where I have created one of the table. So the table name is my table. So I'll be writing this query just to get the output, and it's a long query so that I'm expecting this query to get logged into this slow query log. So as it is slow query, it might take some time. Here you can see that the query took almost 7 seconds to run. Let us go back to Azure portal to check if the query have logged or not. First, let me check if I'm in the right database server. Yes, I'm into the right server. Now I'm going back to server logs. I'll be going at the bottom where the latest slow query log is present, and I click on download. So this is the last executed query which was ran into the MySQL database server. So where you can see the username, the IP address, the query time it took, and how many rows were sent, how many rows were examined. At the bottom you can see the actual query which was actually ran. So now, as you know, this is the query. You can go back to MySQL command prompt and run the explain plan. So we have the query which we ran. Now I'll be adding a explain just before the query so that the explain plan of the query is displayed near us. Here you can see that explain plan is visible, and you can see the table name. You can also see what if there any partitions are involved, any indexes are involved, and how many rows were involved. Also, if there are any type of extra type involved like the where clause, where it was present. So explain plan is one of the method to understand the query behavior and drill down the query. This is one of the important part. So next part will be going more into details, which is called profiling. In profiling, initially we need to enable the profiling, and then we can check more into details. So to enable the profiling, we do set profiling equal to 1. Then we run the same exact query. So the query have finished, and now we'll check the details of the profiles which got logged using this query. So here you can see one query got logged which we ran just few minutes back, and we can get more details of this query using the profiling function. So to get more details, we could type this query show profiles for query 1, and we can see here details of all the time involved for the query, like how much time it took to open the table, how much time it took to prepare, how much time it took to execute, how much time it took to send the data. Also ending the query, closing the tables, logging slow query, and cleaning up. So these all options can be gathered when you enable profiling, and we can easily dive deep more into it. So next, we'll be looking 10 executed query over the database. So this is one of the way we can find out what all different queries ran into the database. So we can find out a trend. The query which I'll be running now, you can get that query from our official documentation, which is under the topic troubleshooting query performance. In this query, you can see different details which are gathered. For example, how many times a query was run, then what is the total time, what is the mean time, what is the max time, how many occurrences that query ran. So all these details are gathered. So this doesn't have a better view, so I'll take this query and show you into a better view. Here you can see select star from my table where id equal to not equal to some value. 8 times are the occurrences of similar type of query, then how much of total time, then rows. So all those details gets logged, and we can easily find out the rows selected, scanned, and total time, mean time, max time. So these all values can be gathered from the query we use recently. Next, we'll be looking into HLL values. HLL values stands for history list len, and it is one of the way to monitor InnoDB garbage value. So to find out the HLL value, we ran the command show InnoDB status, and I'm trying to go back to the first section named the transaction. So where I can see the value for HLL, which is 0. So when the value is 0, means that there is no issues related to garbage value of InnoDB. This value is really important to figure out, and sometimes we need to make sure that there are some automated scripts or any monitoring tool which gather this value. We can also run a query to find out the HLL value, and as I mentioned, there should be some automated script, and we can use this query to always log this value. So if this value is less than 10,000, we can consider it to be a normal value. And when it is from 10,000 to 1 million, so there is very minor lag in garbage collection. Whenever it is more than 1 million, those values needs investigation and corrective actions should be taken against them. We're running same query another time to see the real time value. So here this query gives us the result of the current transaction. So when we run this query, transaction details like when the query started, what are the different details related to transactions gets logged, and it helps us understanding the query age. To see an actual value for the above query, we had to run the query in real times to get the value, or else this output generally does not show up anything. The solution for the HLL value, if you see a very high HLL value, is to investigate the query and transaction running on Azure DB. It needs to be done immediately. The more we delay, the more problem we are. That's the only way we can resolve any workload issues that might be preventing the progress of the garbage collection process. We came to the end of the demo today. So as you might know, every environment can be different. So the best thing which you can do is to always be prepared instead of reacting to issues prevailing in the production DB system. Thank you for your time and going through the demo while I went through step-by-step process to troubleshoot query performance. Here are some important links to the resource page. Do bookmark it. In case you have any queries or any feedback, you can always reach out to the email ID mentioned. Also, stay tuned for the latest update and announcement in all the social media we have. Enjoy the rest of the series and troubleshooting videos. I'll see you again with a new set of videos. Thank you.